Excellent. Hi, welcome. So sorry we had to do our first meeting virtually. I apologize for that, but this is recorded, so you guys can go back and take a look at that later if you need to. And if you have any questions at any time, feel free to stop me, yell. It's all good. I'm Dr. Nanette K. Hartley. You can call me Nan. You can call me Professor. I don't really care. It's not a big deal to me. As long as I know you're talking to me, that's perfectly fine. So I'm going to show you a little bit around D2L first because it's important to know where all your tools are, and not all of us set them up the same way. So I'm going to make sure to show you some things there. And that way we can do that. And these lectures are actually put together for my fast forward course. So we're going to be taking more time through them. At least that's the plan. So a lot of them are scheduled over multiple days. I will do my best to make sure that I am not just running through them. That is my goal. But if you need me to slow down at any time, you have questions about anything, please let me know. That's perfectly fine. Okay. So the first thing we're going to do is talk about our D2L shell. And one thing I have to mention before I get anywhere else is that the dates on the quizzes I need to modify for you guys because they were set at the same as my fast forward course. So obviously we're not doing it at the same speed. So I'm going to need to change those. Those will all be changed probably as soon as I get off of this meeting. So I will make sure that those get updated because those go with each of the lectures. So the number for the lecture is the same as the number of the quiz. So I will make sure that that gets updated. One other thing, when you guys first come into this, you will not see what I see when I look at content, or you may not. Initially, you didn't. So you won't see all of this unless you've done the acknowledgement activity. Now, the acknowledgement activity is one of the things that you're supposed to do before the 14th. It's in here under quizzes. And so there's a scavenger hunt exercise, the acknowledgement activity, and then there's a lockdown browser test. Those are all due on the 14th. Those three are graded exercises. Let me alleviate any fear that you may have. You will all get full credit for them. I just want to make you do some work to get that. So, but the acknowledgement activity is just to say that you've read some of the documents, and that will allow you to see the rest of the content. Okay. As far as our content goes, we have our course documents. There you can find any of the information about the class, what we're going to be teaching, what we're going to be talking about, that kind of stuff. I have a couple of things in here. The syllabus addendum is in here. It's just some I guess I would call it my list of pet peeves, just so you guys are aware of them. There is the schedule for the class. This is a list of my availability, and I'll make sure that that's right. And then there are the exam handouts. Now, the exam handouts will be given to you for all of the exams, so you don't need to worry about that. But I do recommend that you have a copy of them that you can work with while you're doing homework and things, because if you're familiar with where things are and where to find them in that exam handout, it'll make it easier for you on the test. So you have been given a copy of exactly what you will get on the test for that. There's also some stuff in the initial course documents about the scientific method, which is how we approach the lab part of this. Some stuff about test taking. I used to teach for the Prince Review. We taught test taking there. So some things that I learned there. And then there is a section on problem solving and some of my philosophies for doing that. So that's just background information for you guys. There are no grades associated with it. So if you don't feel like reading it, you don't have to. As far as the other materials go, everything is split into the 3 exams that we're going to have. So each exam is contained of the material that's within that. Now understand that when we get to test 2, exam 2, that has to be comprehensive because there are things from the first test that we need to be able to do stuff on the second test. So while I say it's only that material, it's really not, and this date is not right. So I need to change that too. So the majority of the questions will be focused on the material for that exam, but we may incorporate stuff that we've covered previous to it. Okay. Each one of these has a PowerPoint that goes with it. There is sometimes some other information that you can see. I should actually do this as a student. That way you can see what you would see and not what I see. So So the PowerPoints are in there in case you want to reference them. That's exactly what I'm speaking to. And of course I haven't done that yet, so sorry. So the PowerPoints are exactly what I will be speaking to. There is also some in-class practice. When we are normally in class, I will have those pages for you, and we will be doing that once we've finished a particular top work on this. The purpose for doing that is because you can watch me do it all day, but me being able to do it is not the same as you being able to do it. And so sometimes it's really useful to sit down and work on these things when there are other people around that you can talk to see that. And I encourage you to talk to each other, because if you're attempting to teach something to someone else, it helps you to understand what you do and don't know about it. So that's a very useful thing. One of the other things you'll see in here is a link to Alex. Now, Alex is our external homework, where all the graded homework lives. So you need to be signed up for Alex, and this will take you directly to that particular assignment that's been assigned. Now, the due dates come over when I initially put those in there, but if I make a change to a due date in Alex, it doesn't update in D2L. So just be aware that the dates in Alex are correct. The dates in D2L may or may not be. Okay, they should be, but they may or may not be. Each section that we talk about has a homework that goes with it. That homework is due, technically due 2 days before the test. So all the material for exam 1 is due 2 days before exam 1. But I recommend that it be done 2 days after we finish that topic, so that you can make sure you have a good foundation with that material before moving to the next. Okay, so that's what you'll see in the schedule. If we actually take a look at the schedule itself, why did I do that? Sorry, talk to myself sometimes. The dates you'll see in the schedule for the homework have a recommended due date in black and an actual due date in red. So the due date that you'll see in Alex is based on this due date in red. Okay, so that's what you'll actually see in there. But again, the dates in black are what I'm hoping that you can do so that you can keep up with the material. All right. Alex does take time. It's not a minor thing to do. So there is that. You'll also see the due dates for all of your experiments. And what happens with the experiments, I'm going to talk about the lab while I talk about this class. We do not have lab today. So not only because we're not on campus, but I wasn't planning on having lab today. So that worked out well. We do not have lab today. We'll do our lab introduction. I will show you the physical safety equipment the first time we go into the lab, which will be next week. But that is not something we would have been doing today anyway. But as far as the labs go, you'll see that there's a section down here that has all of the paperwork that goes with those labs. Now, I provide that here in case you lose the paperwork that you were given. So I will be giving you physical copies of all these things. You are not required to keep a lab notebook for 110. You can use this paperwork. But remember, if you lose the paperwork, then you lose all the data you collected in the lab, and that means you can't turn in any of the work that's due. Okay. If we take a look at one of these labs, and I'm just going to pick the second one because it doesn't have all the beginning information, you'll see the information from the lab manual about what we're doing and how we're doing it. There'll be the procedure for what you're going to be doing in class. And then there's a pre-lab. So the pre-lab I expect to have done before you come to class. So on Thursday, I will hand you the physical copies of these labs. On Tuesday, you will need to have this pre-lab for experiment 1, not 2, done so that I can sign off on it. And I will be signing off on this. The reason that we do that is that it is our job to show you some of what you're required to do in different areas related to the data that you collect. And countersigning of your data is something that happens in most places. So someone else has to sign off that you had filled in these forms and done this stuff. It's a way to prove that the data was there on a particular date. So that's why I will be countersigning those pages. Understand that if I don't countersign that page, I will not grade it. So make sure that those get signed. I try really hard to do that. The other thing about the pre-labs is if you have not completed the pre-lab when you come to lab, then you will not be allowed to come into the lab and do work. That's a safety thing. These questions force you to look at what you're going to be doing in the laboratory, so you have some familiarity, so that therefore you're not a danger to yourself and everybody else. Okay, so that's why we have the pre-labs. Okay, there'll be places for you to put your data. Okay, so instead of using a notebook, we're going to let you record that here. The only thing, and it is a thing, is that has to be done in pen, non-erasable ink. Okay, all lab documents, whether they're on forms or in lab notebooks, are permanent legal records, so they have to be done in ink. We typically recommend blue just because then you can tell if it's a photocopy or not, but I don't really care what color the pen is as long as it's a pen. Now, there are places in these labs where you'll need to do some processing of the data, calculations. If you want to do that on a separate piece of paper and then put your answers in here, that's fine. I don't expect all of the work for that to go in here because calculations can be messy. So if you want to do that work outside, that's fine. But your original data, anything you collect in the lab, needs to be written directly on this page as you go. Please be aware that if I see you writing on small pieces of paper, I do have a tendency to pick them up and burn them. That is something I do not allow in my labs. And if I see you walking from the balance back to your bench without this piece of paper, because you're trying to remember some number in your head, I tend to walk behind people and sing because it's very distracting. And I tend to pick things with a lot of numbers in them so that it kind of messes you up. The point in that is to build a good habit for you. So when you go to a balance or to an instrument, you need to have that record with you when you do that.
Oh, that's what happened.
That's what that's for. After all of the wonderful calculations for this, because there are going to be calculations, there is a post lab. Now, this post lab is a separate grade in ALEKS. You have two grades that go with your labs. There's the lab itself and then the post lab. Now, your lab itself is composed of the pre-lab, everything you do in the lab, and the calculations. So there are three parts to that grade. The post lab is a grade onto itself. I will be having you turn all of this in together. So your assignments will come in to assignment drop boxes. I will want all of the pages from a particular lab to come in with that experiment, but I will be assigning 2 grades based on that paperwork. Okay. I do expect pictures or PDFs of those things, one or the other. I'm not going to force you to put them together into one document, but it does make my life a lot easier. So I'll just share that. So that's how those are going to work. Do we have any questions about sort of the lab stuff that we've talked about so far? Okay. All right. Then I will go back to our schedule and see if there's anything else I wanted to talk about on the schedule. You will see that there are exam dates. That is a specific date that we'll be taking a test. You will be doing that in class. You can expect to have your exams back within a week. I'm usually done faster than that, but that's what happens. Your holiday is listed here because you do have a holiday in mid-semester. And then there's the discussions. Discussions. Yes, there are discussions for this course. Specifically, there are 3 of them. There is one for your introduction, which needs to be done by the 14th. You just need to introduce yourself to the class. And then there are 2 other ones, and these are lab-based. So this is part of your lab score. I think it's 20%, but I'm not sure. We just decided that, so I can't be quoted on that. I think it's 20%. The discussion is a scenario that you've been given. You've been given a bunch of information, and you're being asked in the first discussion, based on this scenario, what would you want somebody to do? If you were designing an experiment to go into the laboratory to do this, what would you need to do to collect the data that you think you need to be able to solve this question? Well, the question is up here. What you've been told is that you got a set of unlabeled bottles. They have labels on them that say 1, 2, 3, 4, 5. That's what they say. And they are color coded. That's just for me. And it is your job to decide which set of chemicals it is. These are the 4 sets that it could be. and the identity of each bottle. So what chemical is in that bottle? There are certain characteristics that you can collect in the laboratory that will help you make that determination. I don't expect you to know what those are right now. We'll get to that. Okay. But that's what you're being asked to do, is tell me what you would need me to do, or someone else who is as familiar with chemistry as you are, what they would need to do in the laboratory to collect data to be able to solve this question. Okay. So that's the first discussion. So what steps do you need to take in the lab to identify which set? What steps do you need to take to identify the contents of each bottle? And what measurements, if any, need to be made? Okay, so that's the first set. For your second discussion, we're still looking at the exact same scenario. What's going to happen is that you have a set of data that you will be given. Okay, I haven't loaded them yet, but they'll be loaded probably tomorrow. So there will be a set of data that you're given back, and it'll say to you, okay, so here are some things that were measured about this. I'm not going to tell you exactly what that is yet, but here are some things that were measured about this. Use this information to identify which set you were given and what the identity of each bottle is. Now, this is not a group assignment, but I have put you into groups. The reason for doing that is that you then have people you can talk to who have the exact same set of data as you do, who can help you with understanding what's going on. You guys can talk about things together. So that's the purpose of that. Okay, is just to give you other people who have the same set of data. All right, like I said, this is not a group assignment. You're not required to work with anybody else on it, except when you're done, you do need to make comments to one other person's post for full credit. Okay, so again, at the end, you're going to need to identify which set it was, what the identity of each bottle is, and then for any reactions that occur, you'll need to write equations for it. And we'll talk about that later on. So that's actually after the first test that we'll talk about that material. Okay, so those are your discussions. You may not have a lot of questions right now, but if you do, I'd love to hear them. Okay, if you have questions later, when you look at it, that's perfectly fine too. Back to the schedule. I think that is everything that I wanted to talk about with this schedule. Oh, at the end of the semester, there will be 2 VLs, which are virtual labs. These are also present in ALEX. Okay, so in addition to the work that we were doing for experiment 8, where you're actually building some models, I'm going to have you do that in the virtual environment as well. My reasoning for that is there are things you can see in the virtual environment that you would not see with the models that we use. So that's why you're doing that experiment as well. It is a graded experiment. It's 10 points. That is part of the grade that you get for this. Okay, and virtual and experiment 11, the colligative properties, we only do in the virtual setting. My reason for that is that when we do it in the physical lab, we never see actual changes. And that's not the way that should happen. So I want you to be in an environment where you'll see that actual change, and therefore you can manipulate the data in a way that makes sense. Okay, so that's what you've got for that. Okay. I think that's everything I had to talk about in terms of course documents and the schedule and the materials we're going to be covering. There is a review after we get through materials, lectures 1 through 3. That should say chapters. It should say lectures 1 through 3. So that we can go back through that stuff to make sure that you have a good foundation for moving forward. One other thing I will tell you, and I didn't mention this before, in the schedule, we do not go in order in your textbook. We don't. Oh, and I'll show you where the textbook is. Give me just a second for that. You can get to the textbook through ALEX. And so if you follow the link for ALEX, this will come up a little different for me. I'll get into a student view in just a second. Oh, it's gonna make me do that. For the love of God. Okay. could skip the tooltips because I've already done it. I want to skip it. I love it when technology works with me. It's so, so exciting. And you'll be asked to do a knowledge check in Alex when you come in here. Don't be worried about that. Okay, there are a couple of reasons that I say that. One, we can't turn it off. So that's the only reason you have to do it. This is designed for Alex to be used in what they call an adaptive manner. And so they'll see what you already know and you can skip that stuff. We have found that that is not actually helpful to students. So in assigning them in an adaptive manner, it didn't help anybody. They were frustrated by it. They didn't like it. It was very complicated. And so we have made static assignments where everybody gets the same questions. And it's not using this information, but I can't turn it off. So you have to actually go through and do this. Now I have the option to skip it. So I'm going to skip it. But you don't need to pay attention to any of that material. You can just work your way through it and that's fine. And when you come in here, it's going to show you this thing called a pie chart. You are not responsible for what it calls the pie chart because the materials that they talk about in the first semester are different than what we talk about in the first semester. We rearrange things. Your textbook is available through here. If you come down from push the three little buttons, come down from home to textbook, you will see that here. There is an ebook that is available to you. If you want to order a print copy, you certainly can. It will come to you in binder format so you can flip pages. I like having those things, but it's entirely up to you. So the ebook is here and you can use it to your heart's content. If it'll load, that is. Yay, it's a pretty textbook. Awesome. I mentioned that because what you'll see is that for each section that we're talking about, there are chapters and sections that are covered in that. So this is chapter 1, sections 4 through 6 and 7 through 9 for that first lecture that we're talking about. Okay. For the second set of materials is going to be chapter 2, sections 4 through 7, and chapter 8, sections 3 through 5. Okay. So those are the things that so you'll know exactly where in the text this material can be found. Okay, so that's the other thing on the schedule. That's everything I wanted to talk about there. The only other thing I'm going to talk about is that there's a practice for the final exam. Now, under each test itself, you'll see that there's exam review. Part of this is paperwork. So this is the true false part. You will get some true false questions on the test and some multiple guess. I like to call them multiple guess questions on the test. And there are some short answer questions on the test. So this is practice for the true false questions. This is a link to Alex where there are additional questions that may or may not be on that test. The Alex practice is kind of long. I will admit that. What I will tell you is that these things can be extremely useful to you. And the reason I say that is because most of your test questions are either a change from these questions, i.e., it's based on the exact same information, but it's been modified some way. Like it might, instead of having this list of chemicals for which of these elements is a nonmetal, it could be a different list of elements. It could be that it's asking about which of these is a metal, that kind of thing. So there are variations on these questions, or they're exactly the same. That does happen. I do take them directly from the practice sometimes to put into the text. My purpose in doing that is to get you to practice before you take the test. So that's all that's about. But while I write test 1, 2, and 3, I do not write the final. It is a departmental final. And so it's very different than the test you'll be taking from that I have written. A couple of things I'll tell you about the final is that the examples that are here are very similar to what you're going to get in terms of length and in terms of questions. Okay. This is actually an old version of a final that they used to be given. That's why this is here. But they're all formatted much the same way, and they have the same kind of questions that are on them. So that's useful to you in getting to know what the questions might look like, what kinds of things you'll be asked to do. This test is designed to be 90 minutes. 90. I give you 2 hours for your exams. Okay, this is going to be 90. And I will tell you right now, very few students are able to finish it. Now, again, this is not my test. I don't agree with this method of doing this. But there is a school of thought where where tests are designed in such a way that a student cannot finish it. The idea is then they will answer whatever they feel the most comfortable with. I don't like that. I think it puts a lot of pressure on you that doesn't need to be there, but that is how these are designed. And I apologize that that's still what we're doing. We're working on making modifications to that, but that is how this is designed. So I say that not to scare you, but to tell you that there is always a curve on the final, and just go with it. But this is the kind of prep that you should have. Okay? You will still get a copy of the exam handouts to use with this. Right? So any questions so far? Okay, awesome. There are announcements that go on in here. I try not to make a ton of announcements through the announcement tool just because then stuff gets lost. But you know, that is that. Underneath all of this, you will find some links. There are videos that are meant to help you understand some of these materials. There's a set for each unit that we're talking about. So exam 1, exam 2, exam 3. You'll also see that there are 2 in the general section. One is for tutor.com. You have tutor.com available to you for free as a student of TTC. They are tutors that are available 24 hours a day, 7 days a week, and they do employ chemistry tutors. I will tell you right now that most of us refuse to work for them because they require so much knowledge that we would have to review to be able to pass the test to work for them. And we're too lazy. So the people that you would be working with know a lot about this material. So don't worry about that. Now, the other link that you'll see here is for ChatGPT. And I get a lot of questions about why I would be showing you that. I use ChatGPT as a mechanism to review my own lectures. I use it to say, okay, what would you teach? And that's based on the information that they found on the internet. It's based on the models that it's been given. And I find that it writes outlines that are very similar to what I write. And I make some modifications. I move things around based on what I've seen. But I've also asked it all kinds of other questions. And one of the things that it's capable of doing is explaining to you in different ways. So, for instance, if you're really not understanding something, you can tell it, explain it to me like you're Barney, and it will explain it to you in very, very simple terms. It can also use Bill and Ted as a mechanism for talking to you, which I find very amusing. But there are different, you can ask it to talk to you in different ways so that you can understand. And if it says something that you don't understand, you can go back and say, wait, what do you mean by this? What do you mean by that? Now, understand, you can come to me with that too. Absolutely. There's no reason that you cannot come to me with that. But occasionally I get frustrated because if I'm saying something and you're not understanding what I'm saying and we have a difficulty in getting to a point of understanding, if I've tried the ways that I can think of to get you to that point and I don't find it, I can get frustrated. And sometimes students get frustrated with me because I'm not speaking their language. That's okay. It's perfectly all right. But this thing never gets tired and it never gets frustrated. My child is set up on ChatGPT to help her to learn things. And she can follow it down any rabbit hole she wants to go. And as long as you're cognizant that not everything it tells you might be right, you can use it as a tool. Okay? So it is a good way to find information. I find that as you continue to use it, it learns what, sort of where you're coming from, what kind of, what things you do and don't know, how you like to be spoken to, what kind of analogies you like. And so it can be very helpful in being a tutor for you. So that's my little spiel for ChatGPT, and I wish they paid me for that because that would be fun. All right. I think that's everything I had to show you in D2L. Do we have any questions about course materials before I go anywhere else? Okay. Then I'm going to close this out of the way. And I will open screen share again so we can talk about stuff because I let it go to sleep. Okay. So what are we going to be talking about today? Well, okay, let's talk about that. And while we're talking about that, we can talk about what's going to go on in the quiz. So there is a quiz that goes with every lecture topic. So, except for this, well, okay, there's not one before today's lecture. So there's not one listed as lecture 1. There is one listed as lecture 2. The reason that it's done that way is that all of the quizzes are designed to be a review of what we did in the previous class and topics for that day. So in each of these PowerPoints, there is a list of topics. So when you take the quiz, the list of topics that's here is what we're talking about. If it's not specifically in this list, it is not a correct answer for that particular lecture. So I will be asking that you look at the topics for lecture 2, hopefully before you watch that lecture. But if you don't do it before, then that's part of the quiz that you'll take afterwards. You will have until the end of the day that we cover that lecture to take that quiz. Okay. So topics for that quiz. It also is based on a review of the material that we covered in the previous lecture. That's why the first one is for lecture 2, because we'll be reviewing stuff that we talked about today. Okay. I will be going over those quizzes, or at least something like them. They're not exactly the same sometimes, but they're pretty close in the lecture as we review. So don't worry about that. You'll get a chance to see that. So there will be that. Okay. Now, quizzes are pass fail. So you take it, you pass. You don't take it, you fail. If you don't take it at the time that it is assigned, then it's a fail. Okay? I do not reopen them because they are meant to be a measure of, are you keeping up with the material? In the event that you think that the points that you might have gotten on one of these quizzes is if you missed a few and you feel that might be important to your grade, send me an email. And at the end of the semester, I will take a look at it. I promise I will do that. And I've done it every time I've been asked. I have never seen it actually make a difference to somebody's grade, but I will look at it because eventually it will happen. So if you want me to look at that, I absolutely will. Okay. So what are we going to be talking about for this lecture? Our topics for our first lecture, which will be today and Thursday. That's the day of the week that I'm looking for. We'll be classifying matter, talking about measurements, precision versus accuracy, significant figures, scientific notation, and then we'll be talking about dimensional analysis. And we're going to be doing a bunch of examples related to this. Okay, so I want to make sure that everybody's comfortable with that before we move on. Unfortunately, it's something we will need for a long time. So that's what we're going to be talking about in this material. But before we do that, what I would like to do is have us learn to talk to each other. Now, I know this is virtual and I get it. It's a little more complicated doing it here, but in class, I make people do this. And on the discussion page, I'd like to have you include this information. If you've already done the intro, it's okay. You can go back and modify it. There's a reason that I do this. So one, I need to know who you are so that I can take roll. We're not required to take roll per se, but the VA doesn't require us to know the last date of attendance for anybody who's on that program. So I sort of kind of have to take roll. I will do that in lab rather than in lecture. So that's how I keep track of things. But I need to know your name. Names are good. I want to know what your major is, if you have a major, and if you don't, that's fine. You can just say what you're doing. And then I ask why you're here. Now, that's a bigger question. So let's just say, for the sake of argument, that I'm a biology major. In order to get a biology degree, I have to do chemistry. That's just how this works. So the answer that I'm looking for is not somebody told me I had to do this. Because I know you wouldn't, I've had a few students who decided to come and do this even though they didn't have to. But that's not really why I'm asking. What I'd like you to think about, and this is more for you than it is for me, is how is this going to apply to what you're trying to do in the future? Okay. So why would it be important to learn about the chemistry of these things for you? My next question is y equals mx plus b or apples. I want to know if your approach to things tends to be mathematical or theoretical. I can do both. My natural is mathematical. Right? Math is good for me. But I can speak to people in theoretical terms. It's helpful to me to know which you prefer. And so I use that information to work with that. The next thing that's on here, it says word. Yeah, okay, what do I mean by that? Well, this is one of those wonderful icebreakers that we do from time to time. You get one word to describe yourself. Okay, that one word will help me understand your choice for one word, will help me understand who you are as a person and how you approach things. That can be really useful to me too. So that's why I ask that. Okay, I will be taking some notes while you guys do this, but we'll start with me. So again, Dr. Nanette K. Hartley, I prefer Nan. My major in all of the times that I did chemistry was chemistry over analytical chemistry. Analytical chemistry is about how much of what exists and where does it exist. I'm very focused on that. It is not the only major I've ever had. I did a double major in religious studies as an undergrad and have gone back to school for computer programming. So there, although I didn't finish that degree, and I did that at TTC. Why am I here? Well, my why for being here is because I love doing this math. That's why I do this, because I love doing this math. Using the information that's in my head to formulate that math is just something that brings me a lot of joy. So, I am a mathematical person. I can speak apples if I need to, but I am mostly mathematical. And my word is stubborn. I say that as a warning. So sometimes when I get asked a question, I don't necessarily understand the question as it's been intended. I might understand it in a different way. And I get very focused on getting to this point that I'm trying to make. But that point may not be where you want me to go. And so telling me, hey, whoa, Nan, that's not what I was asking. Can you take a step back? Will help me to understand that I'm down the wrong path. Okay, because if I don't get reminded of that, I'll just keep talking and talking and talking and talking about stuff that you don't need to hear. Okay. So that's why I tell you that. All right. Now, I typically ask for victims, I mean volunteers, to share their information with us. I would like you guys to get used to talking to me and to each other. I do run my class in the Socratic method, so I do stop and ask questions of you guys that I'm looking for answers. There are never any wrong answers. Never. Okay. You may not have the answer that I want, but that doesn't make it wrong. Okay. So, any volunteers?
I can volunteer.
Excellent.
All right. My name's Alexandria. I'm a biology major. I'm on track for pre-med. I'm here to learn about how chemicals interact with the human body and how medications affect the body. I prefer a mathematic approach to things, and my word is determined.
Excellent. Lovely. Thank you for going first. I appreciate it. Anybody else?
I could go.
Okay.
My name's Michael. I am just completing my associates in science to transfer to the Citadel for the civil engineering night class program, and I'm here to complete, I guess, my degree and move on to that next chapter of my education. And I guess I'm more of a visual or metaphorical learner, and my word would be focused.
Excellent. Thank you very much. I appreciate it.
Mm-hmm.
Thanks. All right, who's next? Well, don't make me call on people.
I'll go.
Okay.
Name's Chad Casey, and my major is pre-engineering for the Citadel, for electrical engineering. And I am here because I got into a motorcycle accident and now I can't do my regular job, which is an electrician. So I'm going back to school. I'm more of a mathematical person. And my word is grateful.
Excellent. Sorry to hear about your accident.
Thank you.
All right. Who wants to go next?
I can go.
Okay.
My name's McKenna. My major is biology, but I'm wanting to go into the medical field. I remember taking chemistry in high school and I really enjoyed it. It was one of my favorite classes, so I wanted to make sure I took it in college. And then I'm definitely a mathematical person, and my words, I would say independent.
I like it. Thank you. Excellent. All right. Who's next?
I can go next.
Excellent.
My name is Patrick Dupree. My major is I'm getting an associate in science right now. I'm looking to transfer to Colorado Boulder for biological engineering.
Okay.
And I'm here because I really enjoy like doing experiments and calculations and things like that. I'm definitely a math-minded person, and my word's motivated.
Excellent. Awesome. Thank you very much. Who's next?
I'll go.
Okay.
My name is Stephanie Hernandez. I'm a nursing student. I'm trying to go into MUSC's nursing program. I'm here because I also took a chemistry class in high school and I liked it, and I'm interested to see how chemistry works with the human body. And I would say my word is probably centered or concentrated.
Excellent. Thank you. Okay. Who's next?
Everyday.
Okay.
I'm also a nursing student. I'm also trying to transfer to MUSC. Like other people, I also just liked chemistry in high school. I took it in the past, but I do also need it. Um, I would say I'm more mathematical, and a word is control.
Okay. Awesome. Thank you very much. Who's next?
I'll go next.
Okay.
My name is Ethan. My major is electrical engineering. I plan to spend 2 years here and then go up to USC Columbia to finish out that degree. I guess I'm here because I'm trying to figure out because I imagine this has some relation to electrical engineering with like the protons, electrons, the charge. I'm going to figure that out at some point. I'm definitely more mathematical in the way I think about things. I guess my word would be planner.
Excellent. I like it. All right. Who's next? Anybody else gonna go? All right. Well, understanding that people may have stepped away from their computers, I'm going to let that go for now. So thank you everybody who shared. I appreciate that very much. Helps me to understand you guys. So where are we going now? Let's minimize this so I can get back to what I was doing. Okay. So what's next? My remarkable is not helping me today. Any questions, comments, problem, anything so far?
I do have one question.
Yeah.
When we were on the D2L, everything in the exam one is the things that we need to do prior to taking the exam. Is that correct?
That's all the material that we're going to cover. Yes. And then the homeworks for exam 1 are linked there. You can find them in Alex without those links, but yes, that's everything that's due. At least related to that material. It may be due after the first exam, but the schedule will tell you. Okay. All right. When we talk about matter from a chemistry perspective, we have to talk about a number of different things. These are all going to be things that we need to be able to use as words, so vocabulary that we're going to be learning for this stuff. And we'll talk about physical state. I have a slide for that. And we'll talk about purity. There's a slide for that. So we'll get back to both of those. We also have to talk about their properties. So when we talk about their properties, we talk about their physical properties. Those are things that we can observe with no change to the material. So I can look at it and say what color it is. I can look at it and I can say potentially what it smells like. Things like that that I can observe without having to do anything to that material. Okay? And it won't change it after I've done it. Chemical properties, on the other hand, we can't see unless we actually do something to the material, okay? So if I want to look at some of its chemical properties, there are testing methods that I may have to use to be able to do that, which will destroy the material or change it into something else. Those are the chemical properties, and that's what we need to do to be able to see this stuff on the inside, which we'll get to in a couple of the next lecture. But the protons, neutrons, that kind of stuff. So that's all about the chemical properties. And we also talk about two things: intensive and extensive properties. So intensive properties are not dependent on the amount of the material. So if I have a glass of water and I split it in half, any material, any property that it has that doesn't change based on that is an intensive property. Examples of intensive properties are things like temperature, the melting point, the density of that material, so the grams per milliliter. All of those things are independent of the amount of material that I have. But we also have extensive properties, okay? And those are based on the amount of the material that I've got. Specifically, the two that we typically talk about are mass and volume. So if I split that water in half, the volume's no longer the same. If I split that water in half, the mass is no longer the same. So those are extensive properties. So I always think about the intensive properties being the things that are always the same no matter what I do to it. So they're inside of that thing. The extensive, on the other hand, has everything to do with what's around it. Okay, so that's just my thing for how that works. Questions about any of our terms, at least the ones we've discussed so far? We can also talk about the classifications of the matter, and this typically relates to the state that it's in. Now, is this really important? Well, yes and no. So the chemistry that can happen with all of these things can happen with most of the states, but not always. And so sometimes it's important to know what's stated in it to see if it can go through a chemical reaction. Sometimes it's important to understand the state of the material to see if it has enough energy to be able to do something that we're talking about. Now, we typically talk about the energy things in 111, but that's a reason to do that. Okay. Things that we might be talking about with that. So solid, liquid, gas. Hopefully we have some experience with this. Most of us have encountered water in all of these phases. So when we talk about water in its solid state, we're talking about ice. Liquid state is just what we call water, and gas, the vapor state. All right. Those don't require any chemical changes. It's still water no matter which phase it's in. Okay. This is true for other materials as well. All right. When we're in the solid state, things are packed very well together. They don't have a lot of space in between them. Water is a weird example of something different with that, but they're held in a fixed pattern. Okay, they have vibrational energy, so they can vibrate. They have energy and the ability to vibrate within the space that they're in, but they don't move to a new space. In the liquid phase, on the other hand, we have more space in between them, and they're not fixed in their positions. So they can slide against each other and move around wherever they want and how they want within the container that they're in. Okay. But they're free to, so they are free to move. When we then go to the gas phase, we have a lot more space in between those molecules. There's a lot more space. They have a lot more energy. They're very widely separated, and they will exist in whatever space they can occupy. A liquid tends to be contained to whatever it's in, but a gas will come out of whatever container it's in into the room if it's open. Okay, so it will take up whatever space is available to it. We will at some point talk about all of the phrases that we use when we talk about changing states. So melting and freezing, vaporizing or evaporating and condensing, sublimation, those kinds of things. But that is not something we really need to talk about for this. That is something we will deal with in later topics. So questions about our states? Now some, in my opinion, fun things. So element, compound, or mixture. When we talk about our materials, we have to be able to talk about what their components are. All right, this has a lot to do with the purity of the material that we're talking about. So we could be talking about a substance, which is a form of matter that has constant composition and distinct properties. So if I have a sheet of aluminum foil, that sheet is called a substance because everything that's in it has the same properties. It's all aluminum with some coatings on it and some additives to make it a little more useful to us. But it's all constant across the whole thing. Okay. And it has distinct properties because of the shape and the size that it's in. Elements cannot be further separated by chemical means. So if it was pure water, then we can't take that pure water and do something physical like changing its state to separate the water from the hydrogen from the oxygen. That's not possible. If, however, we have a mixture, something like sodium chloride, where we have two things in contact with each other, I can do physical things. So I can filter that. Doesn't really work for sodium chloride, but for some things it does. But if I do a freezing on that mixture, then we get a layer that has the salt in it and a layer that's pure water. Okay, that happens. We can also dry the water off of it, and then we're left with the salt and the water that's been removed from it. Okay, so those are all physical changes that I've made to those things. Compounds cannot be further separated by physical means. Okay, so if I have a compound like H2O, I can't take the H and the O away from each other without doing some chemical things. So that's why it's a compound. Okay. So questions about that? All right. Well, let's take a look at some things because we might be asked about this in a visual sense as well as like, which is this kind of thing. So I'm looking at these materials and I want to know, is this an element, a compound, or a mixture? So what do you say about A? Element, compound, or mixture?
It's an element.
Excellent. What's your logic on that?
They're just individual clusters of, I guess those are supposed to be individual atoms, those little orange dots.
Yeah.
So there'd be no way to break them down. They're isolated individuals already.
Exactly. Awesome. Thank you. I appreciate you sharing your logic. It's helpful for other people to hear that. So, all right. What about B? Anybody else want to venture a guess about what B is? Remember, there are no wrong answers. I mean, okay, technically there are, but well, I would classify B as a compound. The reason that I would do that is because it's made of two things, not a single one. Even though they're the same thing that's bound together, like this could be O2, oxygen, both of them being oxygen. I can't break that down any further without breaking a chemical bond. So I would call that a compound. What about C?
Compound.
Yes. And your logic on that?
They're not different molecules, but the pieces together are bound, are separate. They're not the same. So it's not like you'd have to break the molecules apart to actually separate anything.
Excellent. Awesome. And that is very true. And we could, for something like that, be looking at like ammonia, which is made of nitrogen and 3 hydrogens, NH3. So that's an element or something that is a compound that we could be looking at there. Any guesses for D?
Sure.
Excellent. Why do you say that?
It's a combination of multiple different substances.
Excellent. Awesome. And that's exactly what we're talking about. We can imagine physical things that might be able to separate things. Now, without knowing exactly what they are, we may not know which one would work, but we know that something would. Okay. So that's the kind of thing that you may be asked. And again, it's not just the which one is it, you might get asked the why too. So be prepared for that. All right. Questions about what we talked about so far? Okay. Now, measurement. If there's something I want to measure, I need to know a couple of things to be able to do that, right? I mean, typically I'm not measuring something unless I know what I'm trying to measure and why. So the question becomes, what am I trying to measure? How accurate is that measurement? What do you mean by that? Well, okay. I can think of a couple of things in my house. So I have a scale that I use in my bathroom that only measures pounds. But I have a scale in my kitchen that measures grams, which is really smaller than those pounds. So the accuracy that I have there is really based on, how precisely can I know that number, okay? The other thing that we need to know are what are the units of the number that I'm trying to measure. So if somebody says to you, I want you to go measure this thing, don't you usually go measure what? What are you asking me to measure? And that's because you don't know what it is that you're trying to get to. So if I get asked to measure something, okay, I've got a bag of lemons. How many lemons are in it? That might be a measurement. It might be what's the mass of that bag of lemons if it's being sold by weight. It might be the age of the lemons. I mean, it could be any number of things. Without context, I don't know what they want. And that context is the units of that number. Okay. Now, we'll get back to this. Units are one of my favorite things in the universe, and I'll talk about why, but we'll get back to that. We're going to talk about base units. So these are the things that we typically talk about. So we do use the System International for units. So we talk about length in terms of meters, mass in terms of kilograms. Those are our standard units for these things. Time in terms of seconds. We talk about electric current in amperes, although we don't deal with that. We talk about temperature in Kelvin. Now, we always talk about amounts of substances in moles. Okay, if it's an amount that we're looking for, it's moles. And we do have luminous intensity. That's another one that we have. So these are all metric units that we're going to be working with. And that means that there are certain things that we need to be able to deal with. Because if I'm talking about the number of grapes that I have, I am certainly not going to want to talk about that in terms of kilograms. Because that's a really big number. Kilograms are really big. And, a bunch of grapes, it doesn't make sense to talk about it in those terms. When we talk about metric units, if it'll cooperate, come on. Yeah. When we talk about metric units, going between sizes of units is a bit easier than it is an imperial unit. Okay? So if I'm talking about that bunch of grapes, I wouldn't want to talk about it as kilograms, but I might want to talk about it as grams or milligrams. Okay, those are all prefixes to those numbers. And they tell us that if we want to get back to our standard, which is called the unit by itself, so in this term, grams is our standard unit, then we would multiply or divide by a factor of 10. Okay? So these definitions are here. So for instance, the centimeter, which is listed as cm, will be 1 times 10 to the minus 2 meters. Okay, so we can convert between centimeters and meters. We can convert between millimeters and meters. We can convert between milligrams and grams. We can do centigrams and grams. All of these things have these prefixes that we use with them. Your exam handouts do contain this material, and they have some information. It's not the exact table, it's what I showed on the previous slide, but some information about those units. You will need to know how to convert between these things, especially on the first test. Why is that important? Well, because one of the things that we measure in chemistry, and we often talk about in, say, medicine, is the concentration of things in molar or millimolar. Okay? So that's how many of these things we have in this particular space. So I need to be able to do conversions on that to know what it is in some other term, because it might be important to know how many molecules of this solute are in that bag, but I can't get to molecules by looking at the molarity. I would have to do some manipulation with that unit to be able to do it. Okay? So that's the kind of thing that we need to be able to do. Micro is a very common thing for biology. We talk about micros a lot because it's a very, very common unit that we use with that. Your computers are, megabytes, gigabytes, terabytes, the big ones. So we talk about them in those terms. So it depends on what we're talking about, whether it's going to be a bigger or smaller unit, and you will need to be comfortable in doing conversions between them. Okay? Questions about what I'm talking about there? Let's see what's next. All right. So we do measure a lot of things in chemistry. We measure length, mass, time, temperature. What's the other one? Oh, yeah. Okay. An amount of substances. We do all of these things. Now, please note that mass is correct, weight is not. So mass is the absolute amount of material that we have. Weight is that amount under the force of gravity, which can change depending on if I'm here or in Denver, those kinds of things. So we technically do mean mass, but we tend to interchange those words. So you'll hear me talk about molecular weight. Okay, that is an antiquated term that we used to use. We now are supposed to call it a molecular mass, but when I was being taught, we used molecular weight. So from a technical standpoint, it's always mass. Right? Standard units are defined, the ones that we typically use. Metric units, mass is kilograms, length again is in meters, time is in seconds, temperature in Kelvin, and amount of substance is a mole. There are conversion factors that are in your exam handouts to go between degrees Fahrenheit and degrees Celsius and Kelvin. They're all present, so make sure you've looked at those equations to know how to use them. I did not include anything about time because I assumed, and I made an assumption, so we all know what happens when I do that, that people know that there are 60 seconds in a minute and 60 minutes in an hour and that kind of thing. So we should be able to get through time conversions with that. A lot of these other things we may not know, like how many meters are in a foot or how many, meters are in a yard or things like that. So if we need those conversion factors, they'll either need to be provided to you on a test or from the exam handouts. So if it's not on the exam handouts and I didn't give it to you on a test and you needed it, you either have to ask me about it or assume that you can't do that calculation, because you can't do it without the right conversion factors. All right. Let's see what's next. So again, conversion between things. 1 kilogram is 1,000 grams. There are 100 centimeters in a meter, 60 seconds in a minute. Kelvin is equal to 273.15 plus degrees C. Degrees C equals the degrees Fahrenheit minus 32 times 5/9. I won't really make you do that. Some of the homeworks may ask you to do that, but as a scientist, we typically only work in degrees C or Kelvin, depending on what we're doing. So we need to do those conversions. Okay, you have information on your exam handouts to allow you to do all of this. So you don't necessarily need to memorize them, but you're going to be using them a lot. So it might be helpful to you to do so. Now, a mole, which we will talk about what exactly a mole is defined as 6.022 times 10 to the 23rd particles. Now, this is in your exam handouts. It's just a number that's placed there. It doesn't say what it is. So there's no context given to you for it. But I do not expect you to remember that number. It is in the exam handouts. Okay? Any questions so far? Let's see what we are with this one. Okay. Why do units matter? I said I'd come back to my units. Why do they matter? Well, let's suppose I say I have 12. I want that amount to be converted to moles of substance to do a calculation. 12 what? I have 12, but 12 what? It becomes important that we know what we're talking about. Again, it's the context for that number. So we need to make sure that every number that we put down has that context with it. Okay? It needs to have a unit. I'm very, very particular about this. If I see calculations on a test, even if those calculations are right, that don't have units in them, and the answer you come up with is not correct, you will not get partial credit because I won't be able to follow what you did. Okay? It's just not possible to deconvolute all of that without looking at units. Those units will also determine what kinds of calculations I can do. So, I mean, if I have $12, I'm not going to be able to, well, oh, okay, I could convert that to moles. I could. But it wouldn't be typical for me to do so. I mean, what would be the purpose? So, the why or why not of if I can do those calculations has a lot to do with the units that we need. And so those units need to be written with those numbers. Now, if you want a real life example of how this works, Chemistry in Action section 1.7 has an example of how this works. Here's another one. Hubble telescope was built both here and in the UK. There were parts done here and parts done in the UK. A bunch of numbers, tabulated numbers, were generated here in the US and then sent to the UK for additional manipulations. Those numbers were sent without units on that table. An assumption was made here that they were a certain unit. An assumption was made there that they were a certain unit. And the assumption on what units they were was not the same. So the calculations that were done on this end and the numbers sent back, which also didn't have units, were in error because they weren't what they thought they were supposed to be or what in their head they should have been. And so the numbers that came back, another assumption was made about what it was and what it wasn't. And that led to a $2 billion mistake on the Hubble telescope. That's a huge deal. So units are really important because you may have people who have different backgrounds, different areas, who don't know what they're looking at, who are making different assumptions about what those numbers are. So we need to make sure that we're including our units so that we aren't making wrong assumptions. The other thing I'll tell you about units is that it will make your life extremely, extremely better in doing your math. Okay? And we'll probably talk about that next time, depending on what comes up next. Oh, I'm going to mention derived units. We're going to stop pretty soon for today and pick this up on Thursday. But derived units are things that are not based in quote unquote defined units. So they come from squaring things, cubing things, dividing things, that kind of stuff. So we do have ways that we talk about the area, which is typically a meter squared, volume, which can be meters cubed, other things that we can see in terms of volume, milliliters cubed, cubic centimeters, things like that. Density is usually mass per unit, is defined as mass per unit volume, and typically reported as kilograms per meters cubed, but density on a liquid, if we're dealing with a liquid, we typically don't want it in those units. We want it in something that's more relevant to what we're talking about. And so we often report that as grams per milliliter or grams per cubic centimeter. Okay, so it's important that we know what those are. But these are all derived units, meaning that they come from a combination of our primary units. Okay, questions about that? All right, that's where I'm going to choose to quit for today. If anybody has any questions, feel free to hang out. That is not a big deal. At this point, we haven't covered enough to do any sample calculations, so I'm not going to hold you for today. Remember, we have no lab today, so you will not need to see me again today. I will be handing out on Thursday the physical paperwork for the lab so that you can have the pre-lab done for the following Tuesday. And at this point, you don't even have any homework to do. So go be an easy at this point. So questions, comments, problems, anything anybody wants to talk.
I have one question.
Yes.
In class, when you're doing your lecture, you're gonna do PowerPoints, right? So all of the PowerPoints are available on D2L that we can print out?
Yes. Yes. And I will show you those. They are. So this lecture is under content. Exam 1, matter and units to measure. And here's the PowerPoint that I'm speaking to. So yes, feel free to print them, write all over them, or do it electronically on your computer, whatever. Yeah, that's what I would do. Yes.
Okay.
Other questions? Well, if you have no other questions, then you are free to take off. If anybody wants to hang out and ask questions as people wander off because you're shy and you don't want everybody listening, I understand that too. So I will be here until everybody has exited the room. And I will see you guys Thursday.
Hi, so I do have a question. I just wanted to wait till everyone else didn't have to stick around for it.
Sure.
I know you talked about this when the class first started, but in my D2L, I
Mhm.
only have the course documents. You mentioned that there were 3 things we needed to do to gain access to the rest of the course. One of them was the introduction. What were the other 2?
So the only thing you actually have to do is the acknowledgement activity. It's the only
Acknowledgement
one
activity, okay.
that's required to see the rest of it. You need to have the scavenger hunt and the lockdown browser test done by the 14th as well, but that it's only the acknowledgement activity that has to be done before you can see the rest.
And that was under quizzes?
Yes, that is correct.
Beautiful. Okay, I think that was it. Thank you.
Excellent. Have a great day.
You as well. Bye.
Thanks.